is like just kind of reviewing what we did the last couple days, and some of it's new. I don't know if any of you have seen the residuals on Khan yet. That's what we're going to get into in this unit. Beginning, let's kind of review it, but let's see how we do. If we think a variable x may explain another variable, we call x a what type of variable? Explanatory. Because it explains the other variable. Like how many toppings you order on a pizza explains the price of the pizza. And y is a response. Because it's a response to, like the price is a response to how many toppings, for example. Displays the relationship between two variables. So this is a scatter plot, which I'm going to show you how to do on your calculator in a little while. In examining a scatter plot, we look for, how do we describe a scatter plot? There were three things we talked about Wednesday. Form, direction, and strength. So, form can be like, it's usually just linear or non-linear. Direction is one of your choices there. Negative, and then strength, we get that like weak, moderate, and strong based on R, like how close those dots are to the pattern. Try that multiple choice question. I don't even know what A is saying. Don't put A. You are highly correlation. If you look at B, perfect correlation wouldn't be R equals 0, it would be R equals or 1 or negative 1. So C, correlation is not affected by which variables called X and Y, that's the true one. Like if there's a relationship between how many calories I eat and how much weight I gain, that relationship exists no matter how I measure it. So if you just envision a bunch of dots like that, if you flip the variables, all that happens is they all flip over this diagonal y equals x line. So it'd be like the same amount of tightness. It would just kind of point a different direction. So that would not change x. That would not change the correlation. D as follows: correlation is very affected by extreme values. I don't know if we talked about that much yet, but let's say I have. Look, we have a little. If I have that. That's fairly strong, right? Well, if I just put a dot, like this is still part of my data set, and I'm like, oh, there's another point over there. Did I just strengthen the relationship or weaken the relationship? Weakened it because everything's not so like tightly packed anymore. So that's an extreme value, and that is going to have an effect on the correlation. What if this point's gone now? I erased it. What if I put a new point on this graph right on the line? Strengthen it because you're like tightening it even more, right? And then E is just like trying to make things up. So we've done this. What's the predicted Y value? How do we notate that? Y hat. You gotta put that hat on. Explanatory value. Variable is X. Your slope. Your calculator calls your slope A and your y-intercept B, although it doesn't. You can call this whatever you like. Your calculator, if you notice, offers you the chance to do it as y equals ax plus b, or is it bx plus a? Like it gives you both, I think. If you scroll down past the ax plus b, there's actually like a bx plus a below. So you can choose. Like all that I care about is the number in front of the x is the slope. The number chilling by itself is the y-intercept. I don't care if you call it a, b, m. So the way that this is created, this is called the least squares regression line. And it just happens, like your calculator does it. If we were to do the calculations by hand, which we never will, we would do this too. It just kind of comes out in the way that you calculate it. The idea is every point, so we have this prediction line. This is our y hat. That's what we expected would happen. That's our guess. But then this is what happened. So this distance here, from the point to what was expected, is called a residual. It's like the leftover, like the residual, the residue. So we expected this, but there's this extra amount. This is a positive residual. Why do we think it's positive? Above the line. And then, so there. And then these ones below, this would be a negative. Residual. So two facts. You add up all the residuals. Any guesses what you get? You get 0. So that's just like a function of how the line is created. You don't ever have to worry about making it 0. You would just need to know that if you add them all up, you'll get 0. So like whatever this amount, if I added these two positive ones up, that's like the error above the line. If I added these two negative ones up, that's like the error below the line. And they all just cancel out. And then the second thing, so this is called the least squared regression line, because if you square every residual, add up the values, so what does squaring do to any number, whether it's positive or negative? It makes it positive. So that's going to make all of these positive values. So if this was like 2 below, now we count as 4. This was 3 below, now we count as 9. Again, you don't have to do this, I'm just explaining to you where it comes from. The LSRL, which is the regression line, minimizes that total. So it's trying to draw that line through those dots in a way that makes the square of those distances as small as possible. You'll never have to do it, you just kind of have to understand that's what's happening. So just, I think it's what you think of, it's just you don't think about it that way. If I had just like those 4 dots, and I drew that line, and I squared all those values, that'd be like much worse than if I had drawn that line, right? Does that make any sense? Some people are looking at me like I'm nuts. I mean, I might be, but I still want to show this. So, if I drew, I'm just going to draw like a terrible line. I'm going to do that. Well, doesn't that make like those distances pretty large? But if I drew a better line, now those distances just got smaller. Does that make sense what I'm trying to say? And the least squared regression line will draw that line so that those distances are as small as possible. And they all have to 0. And again, you're not going to have to do it, you just got to understand. Right. We're not going to do what they're doing here. There are some things in this class that I'd say like the juice isn't worth the squeeze. So for example, this would probably take like a full day of class to practice this thing that we're skipping. And it's like 1 out of every 2 or 3 years there's a multiple choice question on it. So it's one of those like our time is better spent other places. Like as a class, if you individually want to make sure you're getting every single thing, you should look at that. I'm okay with not. People get 5s all the time without like the way I do it, skipping like the things like that. The average score, like most people pass, the average score is above 3. I wouldn't worry about passing the tests without like the few things I'm going to skip. But this is one of those that if you want, take a look at that on your own. But to get your calculator out, I want you to put the x's into L1 and the y's into L2. like y equals. And just make sure it's clear. Sometimes there'll be just like some random things in there that will mess up your graph. So make sure all those are clear. You might even want to scroll down. Some people like to hide things at like y21, and you're like, let's go down to y0. Does everybody have anything when you scroll down? I see like swear words nowadays. I'm just giving you ideas now. You can type by hitting the alpha.
You never.
We need to like type words. You didn't know you could type words.
All the letters. That's two.
They also have all the numbers. Okay, so then go. See where it says stat plot there? So it's like second and then y equals, or second stat, however you want to say that. Second and then that, and you should get to that screen. We good? Let me know if you're like not caught up to where we are. You're not seeing that? You what? Oh, okay. Oh, you're doing the, are you the phone app still? So when you go to your stat plots, my guess is yours says off right here. Maybe it doesn't. But we want, first thing we want to do is turn it on. So we're gonna hit enter. Like mine's on the off one, but if I just hit enter on, now it knows it's supposed to take the data in L1 and L2 and like use it to graph something. You look at these graphs here, it will do all of these. So that top left one is a scatter plot. That's what we're gonna do. But like that's a histogram. That is a modified box plot with a dot on the side there. This is a box plot, which is not cool enough to be any of these stats. I don't even know what that's supposed to be. But just put, like, you want the top left one. That's a scatter plot. You want, like, I put my x values in L1 and I put my y values in L2, so make sure that matches where you put yours. And then you can choose, like, what kind of dot you get. I think on the cool one, you can choose, like, the color and, like, the symbol. Yeah. So then hit zoom. Like top middle, it's like your F3, hit zoom. And we want to go to number 9 is zoom stat, so it knows like I'm supposed to zoom in on the ones that were in those lists, because that's where the statistics go. Hopefully you get something that looks like that. If you did not, let me know so I can come take a look at. We're all good? Zoom stat. Alright, so now go back to your main screen and do stat calc. This is what I was saying before. They offer you the option of linear regression A plus BX. All that does is put the y-intercept first and the slope second. Like they're just changing the letters, which to me is confusing. But just remember the number in front of the x is your slope, no matter what they call it. Whatever by itself is y-intercept, no matter what they call it. So go to number 4, linear regression, and do it. And we're just going to write down the equation. I'm not writing it like to impress anybody, like in a formal way. I just want to be able to type that into my y equals. So I'm just making like a little note for myself. I'm not worried about labeling or anything. So if you have the fancy calculator, I think it says like store regression equation. That's one of your options. If you put y1 there, which I'm not worried about, it'll do it for you. But let's just do it the other way. So go to y equals now. No, sorry. Go to actual y equals. And I want to graph that line that we just wrote down the equation of. So mine was 1.338x minus 29.3. And there is kind of a fancy way to do this with the story, but it rarely is necessary, so I'm not going to worry that much about it. Then if you go zoom stat, you will see like the line of best fit going through those points. Okay, so just a quick review here. Positive or negative residual? Negative what? Below, so positive or above. I took all those distances to the axis, or to the line, and add them up. What I get? 0. Okay. Turn the page. So we have our equation. I've already forgotten what it was. So we're going to skip. Don't worry about step 3. We're skipping that. We used our calculator instead. So our equation is y hat equals 1.338x minus 29.3. Is that a good equation? Is that a complete, thorough equation? Not, because I have no idea what x and y are. And I legitimately don't. I just start typing those numbers. So I'm going back to look at what x and y actually are. I'm confused by this. So is x like the teacher evaluation or the student grade? What does that mean? Thank you.
Wait, did you just like?
Yes, that's not what I was asking. But you guys look and see what I'm looking at? So teacher evaluation and grades both on a scale of 100. The results are given below together with the average for each student is x. So that's like the grade. Must be the grade. So x is the grade and y is like the teacher evaluation. So if you have a good grade, you're going to evaluate me well. And if you don't, you won't. I think that's the idea. So then I'm going to go over here and I got to say x equals grade, y equals eval. Yeah, that's right. Just looking at the next two questions. So use your equation to predict what evaluation Mrs. H will get from a student who scored an 81. So is 81 the x value or the y value? X value, so we're going to plug that in for x. So it'll be like 1.338 times 81 minus 29.3. So I get 79.08. That's the predicted score. The y hat, that's your prediction. This is your actual score. Is that a positive or a negative residual? And why? People are just guessing about it. It's below the thing. Does anybody have any questions? It's below the thing. Do we all get it now? I don't know what it is or the thing is. What do you? So,
You know what I mean.
well, but I don't know which order you mean it. So I just want to.
The 79.08 is below the thing.
Okay, is the 79.08 the dot or the line? It's the line.
Dude, okay, you know
No, you're good. You're right. I'm just making sure we don't say like thing and stuff. So this y value that it's predicting is there. This dot is higher than that, right? That's like the actual dot. It's above the prediction line. So is that a positive or negative residual? It's a positive. Try part C. We've done this a couple times, but it's not like the easiest for students usually to remember. So let's practice. Just put the stuff by the thing.
what I did though.
I just needed to know which order. Though, you know what I mean?
Well, I was wrong. So.
Oh, really? facing forward? No, why don't you turn it? Just because, like, no one else does.
I like mine. See a little bit. Mostly, I would not change mine.
So you like it better this way?
Oh, we should.
I'd rather like these way around my face.
You only have to look. It's not like you're cool like this. Yeah. Okay. So the slope, first of all, what is the slope? 1.338. So I think it's very helpful to go through this, whether you're doing it in your head or on paper, this kind of process where you're like labeling, okay, I know slope is y over x. In this situation, that is eval over grade. And then go from there. So as grade increases by 1, true or false? The evaluation goes up by 1.338. False. We expect, right? Not automatic. We expect the eval to increase by 1.338. Why is it increasing and not decreasing? It's a positive slope. So part D, the way they phrase this is interesting because we're going to jump off this in a second. Do you think the student grades and evaluations are related? They are for sure related because we can see this pattern. So yes, they are related, but there's a big but here coming. I just learned this word from my kid.
What? You just learned the word.
Oh.
It starts with a G.
Oh,
What is that?
Yes.
Is that like an inappropriate?
It's like a word for butt.
Right, but is it like an like I should say it?
It's I guess.
I
wouldn't say
it.
it.
It's not like a.
It's not a bad word, but don't say it.
Okay.
It's like
It's
harassment.
Got it.
It's like harassment, I guess.
Oh, okay.
I think
Yeah.
it's.
Alright, never mind. Stop. I'm gonna go like delete that part of it. I didn't say the word. I don't even remember it. Yes, they are related, but like separately, and more importantly, this does not mean, it probably does in this case, but it does not necessarily, let's write that, does not necessarily mean one caused the other. In this case, it probably did. Like when I was a student, if I had a better grade, I was probably more likely to give the teacher a higher evaluation. If I didn't do well, it obviously couldn't be my fault, right? It must have been the teacher's fault. So they got a poor evaluation. So the main idea here is correlation does not equal causation. Probably heard that in other classes. Heard it a million times. Like where? What class? Okay. So, for example, the number of churches in America has gone up drastically since the 1800s. So has the number of murders. Does that mean churches are causing murders? Does it mean murders are causing churches? Or is there like a third variable there that's really behind both of those? It's like there's just way more people here, so there's going to be more of all of those things. So, like when you say you've heard it before, raise your hand if you've talked about this before. So it's not ever, okay. It's like certain classes. So here's another one. There's a study done that showed a strong, positive, linear relationship. It looks beautiful. It's almost a straight line between ice cream sales and homicide. This is actually interesting. So, as ice cream sales go up, so do homicides in New York City. And I would have never guessed this. What's the variable there that is like actually making both of those go up? Because there's not more people in the city. Yeah. I was thinking, like, go back another level. Why are there more people outside? Because it's warm. Would you guys shut up? So I actually looked this up. There are way more murders when it's warm outside. Like, murderers don't like to be cold. I guess. So, shh. I'm just trying to make the point that ice cream sales are not causing homicides. Murders are not causing churches. There's sometimes a third variable. So there is a lurking or confounding variable that is influencing both. What's up?
On the topic, so my only question is, most crime is increased in the winter. Why is it only homicide that's increased in the summer? I want to know my class.
I don't know that.
Why wouldn't homicides be up in the winter when it's cold outside and nobody places to stay, so they kill the people living in houses?
Because it doesn't make sense with the example that I'm doing in the packet. So, I don't know. That's true. There's more crime in the winter. Maybe there's more violent crime in the summer or in the night. Anyway, let's move on. Alright, shh. Stop. I feel like I've lost control. We are skipping the coefficient of determination part for right now. That is not something we're skipping and like not coming back to. That is valuable. We will talk about it. Just not right now. We're going to keep talking about residuals. In most cases, no line will pass exactly through all the points. What would R be if you passed through all the points? 1 or negative 1. Because we use the line to predict what from what? Are we predicting X from Y or Y from X? Predicting Y from X. The prediction errors we make are errors in Y. Like what we're predicting is where we're going to find errors. We're predicting Y, so we're going to find Y as an error. The errors are in the, that you're supposed to put here, vertical or horizontal. I drew those little lines to the prediction line. Are we drawing vertical lines or horizontal lines? Vertical lines. A good regression line makes the vertical deviation of the points from the line as small as possible. That's like your least squared idea. A residual is the distance between an observed value and the expected value. This is how you calculate it. So residual is the observed value minus the predicted value. So I just thought, because of the new vocabulary I have now, you might remember OP. Observed first, prediction second, OP. I have always taught it as you're in AP calculus, so it's the actual minus the predicted. Or did I say calculus? AP statistics. So AP in that order. Or you might be like residuals are by OP, so observed minus predicted. So it's also Y minus Y hat. If you're into symbols to remember. If the residual is positive, the observed point lies above or below the prediction line. Would be above. I keep saying like prediction line just because it's too long to say least squared regression line over and over again, but that's what it is. Then if the residual is negative, we are going to be below the regression line. But you only get to call one thing. Otherwise, it's like, what are you talking about? The thing's above the thing by like some stuff amount. All right, turn the page. got Ford F-150 that is losing value the more it's driven. They have already done the regression line for you, although that equation sucks. Because I would need to also say X equals miles, Y equals price. Why else does that equation suck? Like, it super sucks. I'm kind of pissed at it. There's no hat. What that equation says before I put the hat on is every single truck you can plug into that equation and get the exact price. That is not true. It's an overall estimate, average, best fit. So, these 2 points up here, positive or negative residual. Positive. And again, that's the actual value, that's the predicted value. So actual minus predicted will give you a positive number. If you're below, actual is down here, minus predicted, so you're going to get a negative. They're asking us to find the residual for that point. First of all, let's find that point and circle it. Looks like it's that guy right there. So should our answer be positive or negative? Should be negative. So that's like one thing. If you forget the equation, sometimes you can just kind of look at it and be like, I know it's supposed to be negative, so if I do the order wrong and get like 4, I'm just going to make it negative 4. I just screwed up the order. Sometimes you don't have the graph though. But the idea is you're taking the actual y value minus the predicted y value. That is a residual. So for that point that they just gave us, what is the actual y value? Y is price. The 21,994. That's how much that car actually sold for, or is worth, or cost, or whatever the Auto Trader does. The predicted y, how do we get the predicted price? We plug x into that equation, and what's x represent in this case? Is miles, so the predicted is going to be negative 0.1629 times the number of miles, and then plus that 38257. So we're going to type all that in, figure out predicted y, and then just subtract. Should the number I get here be bigger or smaller than 21,994? It should be smaller because that point is below what we expect it to be. So I get, no, this should be bigger, yeah, because that's the prediction lines up here, sorry. That's why I had, that's why. So it should be bigger, that's bad, that's my bad. You know what we just talked about? Ice cream, murders, New York City.
Oh, yeah.
Like last year you went there at the same
time.
Yeah.
And you guys figure it out?
She said there's more crime in the winter, so now I'm just confused.
There's more money.
That's related. Sorry, I
She don't like that.
yeah. I wouldn't
I
get
would say that she is, but you like it.
What's up?
So what you think?
So, in my chronology class, we learned that there's more crime in the winter than there's in the summer.
Well, my packet said the opposite. And we just go by the packet.
Yeah,
Monroe.
She wanted to tell you all this, tell the whole class all your dirty laundry.
So I get negative 4765. And I'm just gonna kind of compare that to the graph and be like, I got a negative number. It should be that point should be below the line. It is. That kind of helps confirm that I'm on the right track. It doesn't mean I got it right, but it means I didn't get it like horribly wrong. Okay, residual plot. So if you took this graph, which is like a diagonal line, right, and just rotated it so that that line is horizontal instead, you have basically made a residual plot. The residual plot is just supposed to show you like the distance between the actual line and the line in an easier way, and it's really, you can see like on the, if you just look down the page, but it's really just this. So this is horizontal now. Close. So then you can look through, it's just easier. Positive or negative residual. Positive, positive, negative. So that's fair enough. So that's all this graph is down here. It's just that graph up there, flipped like sideways. And the residuals go over here, and the miles driven go over here. So the important part of a residual plot, turn to the next page. The reason that matters, you will get one of two scenarios. Your residuals plot will either have a curved, obvious pattern, like it'll be very clear, it'll be screaming at you that this is, like I can't look at this and be like, oh, I can kind of see a line there. That's just like a parabola, basically, right? This means a linear model, using is not appropriate. If you get a curved pattern here, that means that the better way to do this would be like a quadratic model or a power law model or a logarithmic model or something. And we don't do any of those. We just have to know that it's not linear. If you get randomness, so it just kind of dots everywhere, some above, some below, that means a linear model is appropriate. So let me just show you real quick on the calculator how that would kind of work. Can I move this sheet of paper? So I know y equals x squared is definitely a curved pattern. So my x values are like 1, 2, 3, 4, 5, 6, 7. And I'm doing x squared. 1 squared is 1, 2 squared is 4, 9, 16, etc. So if I graph that, I get that. So if you did a regression, so if I do a calculation, one variable stats, blah, blah, blah. Dang it. Hold on, my diagnostics are not on. It's going to give me like a pretty high R. But that doesn't mean it's a line. So that R value is 0.977. Like I can fit a line through that and make it look darn good. So that's 8x minus 12. Put that in there. So like that kind of looks like it fits, right? Kinda. But if you flipped it and made it, that line horizontal, now it's a residual plot. Can you see how there's a curved pattern? That would indicate that this data is not best served by making a line, but it would be better served by like putting a curve through it, which makes total sense because it's y equals x squared, which is the curve. But if I didn't look at the residual, it might be hard to tell. But with that, I can tell that yeah, that's definitely a U shape. So that's randomness. You can get dots like all over the place as long as there's no curved pattern. That's all I got. Questions for me? Some of you got to like residuals yesterday in Kyle, and you were kind of stuck. So now we've gone through them. And yeah, we'll see you on Monday.